Hello and welcome to Tvaritam.AI. In this video, we are going to talk about missing values in our data. Missing values can occur in two places in your dataset, either in the target variable or in the input features that we are going to use to predict the target variable. If target variable itself has missing values, the most common approach is to drop those rows. The reason is simple. A machine learning model cannot learn without a label. Rows without a target value does not contribute to the learning process. Another option can also be to re-upload the dataset. If the missing values can be recovered from the backend or through a domain expert, we can check and then re-upload the data. However, imputing the target variable is generally not recommended because it can introduce bias into our model. Therefore, in most of the cases when the target label is missing, the safest approach is to drop the rows. Now, when it comes to input features being missing in the data, there are two ways that it can occur: simultaneously missing features and individually missing features. Simultaneously missing features occur when multiple features are missing in the same row. If many features are missing in a single row, the overall signal quality of the data instance becomes weak, and dropping the row may be a reasonable approach. However, before dropping, you should be careful that you might lose out on some information, so it is something you should avoid in general. If several engagement metrics are missing for a customer, the missingness itself can carry information. It might indicate that the customer is inactive or has churned. In these situations, instead of simply removing the data, we can add a missing flag to capture this signal. The flag becomes an additional feature that tells the model that certain values are missing, which itself can be predictive for the machine learning model. Now, when it comes to individual feature missing, we have different approach. First is to add a missing flag. Again, if missingness itself provides useful information, we can add a flag. For example, if credit score is missing, it can again indicate that a new customer has joined who has not yet established a credit history. So that flag means that missingness itself is a signal. Second approach is to drop. Now, dropping is something again we should be more careful about because we can lose information, but we will discuss that as an option. So if a feature has very low predictive value or too many missing values, it can be better in certain cases to remove the feature entirely. For example, if the feature is not very important, like middle name column, many people may not have a middle name or may choose not to provide it. So in such case, if a large percentage of the column is missing, dropping the feature can simplify the dataset without harming the machine learning model. Dropping the rows can be utilized if we have a large number of rows. For example, let us suppose we have more than 500,000 rows and only a small number of rows contain the missing values. We can drop the rows. The loss of a few observations will likely have minimal impact on the model. So out of 500,000, you could safely drop 20, 30, 35, 40 rows, but you should be careful not to drop or remove a lot of dataset, because when you drop the entire row, you also lose information in the features or the values that were there. Now, third is the imputation. We can impute the missing values. For numerical features, mean is the common approach when the data is relatively symmetric and it has few outliers. Symmetric means the distribution of the data is symmetric. Imputing with mean can be a common strategy in this case, and example could be age, average speed, where the mean represents a reasonable central value. Second is to impute with median in cases where the data distribution is skewed. The data contains a lot of outliers. The median is a better measure for central tendency. And for example, annual income can be highly skewed because a small number of individuals may have extremely high income. In such cases, imputing with median can produce more stable results. Third is impute with mode, and that is mostly utilized for categorical feature where mode is the most frequently occurring category. So if you have a column such as a city, a color, a country, a membership type, then mode is the way to impute. Next is temporal imputation, that contains forward fill and backward fill. These techniques are used when there is a time series data. For example, if temperature data is missing, in that particular instance, instead of averaging the data completely, the whole average of the yearly temperature, we go with the previous day's value or the next day's value, because today's temperature is more closer to yesterday's or tomorrow's temperature as compared to the average temperature around the year. Same idea can be applied to daily sales data. And one important thing to check when you are using temporal imputation, forward fill or backward fill, that there must be an existing non-null value in the direction you are filling from. Last is to impute with a constant value, domain imputation, where we can replace the missing values with a domain defined constant. If your domain suggests a value that represents an unknown state, you can directly replace the null values without the constant, with that constant. Now, important thing to note about flag is when you add a missing flag, it could be for individual feature or for simultaneously missing features, you should not drop the corresponding rows. If the rows with missing values are dropped, the flag column will no longer carry meaningful information because the rows that contain the missing values will already be removed. So that will make the flag irrelevant. You can use the flag as in the software also with other features like imputation. So add a flag and impute. But if you add flag and drop the row, that will make the flag irrelevant. Now moving towards the implementation, what you see on your screen is the feature categorization tab, where the output feature has been classified as the churned. Now all other would be the input features. Now when we want to look for missing values in output features, we go with nulls in target. Nulls in target, you can see there are two rows where I don't have the output variable. In this case, I can re-upload if I can get it corrected from the backend, but if I can't, then drop or remove the rows. So you can just select the option, click on apply. These two rows have been deleted. Now simultaneously missing feature is an optional case here because your machine learning model will work perfectly fine if you just impute or take care of the individual feature missing. But simultaneously missing features again can give you some meaningful information. In this case, let us go with credit score and customer feedback. Our assumption could be that people with no credit score, no customer feedback history are new customers that have never generated the credit score or have given any feedback in the past. Display effect is used so you can see how it affects the data and also see the data distribution of the individual features. For example, you see that churned in null rows is 0.44, churned as total is displayed, credit score, the distribution of that continuous feature, and customer feedback, you can see poor customer service is the most occurring value, that is the mode, which is unfortunate in this case that the customer service is poor. Now moving forward with this, we can identify that in case of the present situation, when there is null, the mean value is a little bit higher than the actual mean value when there is the data is present. So maybe there is some difference when both of these are missing. Still the number of rows are very less, but we can still see that mean value is 0.44 as compared to 0.314. So people are more prone to churn if they have both these values missing, can be an assumption, and we can add a flag. So I'll click on apply. Similarly, when you go with individual feature missing, you can see credit score, you can do the display effect option. You can see how the distribution varies for 0 and 1, that is your present and absence for your output variable. The customer who churned and the customer who did not churn, and how the null rows and the rows with all the data shifts. So here you can see credit score, we will go with impute with mean because distribution we know is slightly normal, and also that it has a boundation that credit score cannot have a very high value or outlier. You cannot have a credit score more than a certain value, right? So impute with mean. Education, we can also display the effect, see if a flag is required, and in this case it is a categorical variable, so impute with mode. Lastly, customer feedback, display effect is always a very useful thing to do, so you can decide if you want to add a flag, also decide what is the way to go. In this case it is categorical, so mode. If you can see the distribution, the mean and standard deviation, you can decide between mean and median, and you can also decide if you want to impute with a certain value or if you want to add a flag depending on your domain as well as the distribution. Here we will go with impute with mode, and that is how we have taken care of all the null values. When you import the dataset for model training, you have to take care of these things, but when you run for prediction, you just need to give the testing dataset, and all these pre-processing, all these null handling that you have done in your training would be automatically applied when you import the data for prediction. Thank you.